The wines from Vino Verde have long been known for their vibrant fruit, low alcohol percentage, and refreshing qualities, a combination that makes them one of the most versatile partners with food. We are now interested in figuring out the dominant factors that determine the quality of red and white wines from Vino Verde. Therefore, we examine the wine quality dataset, which is available on kaggle.com. We convert wine qualities to factor to better visualize how different features may have an impact on the overall wine quality and present our result with the R Shining app. In our R Shining app, you can access the 6 main sections from the top of the page, which are the data table, variable t-test on quality score, t-test against red and white wine, predicted quality score, variable histogram, and distribution. Now, let's go to the data table section first to take a look at our dataset. The wine quality dataset has 13 attributes and 1599 rows of data. We are showing 25 rows of data per page. The 13 attributes are fixed acidity, volatile acidity, citric acid, residue sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, the pH of the wine, sulfates, the alcohol percentage, the quality score, which is scale from 0 to 10. 0 represents the worst and 10 represents the best. And the category, which indicates whether the wine is red or white.
Alright, so after a basic introduction on our data table, now we want to do a more exploratory analysis based on some of the plots that we have. So this is a basic distribution across different variables. So on the x-axis, it gives you the category, the variable that we're looking at, and the y-axis has like a count of different level of the variable. So if you look at volatile acidity, you can see that across the wines that's currently containing our data sets, they kind of peak at a bit less than zero point 0.4, about like 0.25-ish. And then we can also look at chlorides as well, where you can see there's a majority of them reaching about 0.045. So one thing to notice that this only reflects the wines that's currently contained in our data set. So it does not have any informative value in terms of how wines overall has certain level of different elements. And then in addition to looking at distribution, we can see how each component of wines across different category of wine relates to their quality scores. So for chlorides, you can see that, but across different wine type, red and white, there's fairly similar performance distribution for the chlorides level across quality score. Whereas if you look at more extreme, so this is alcohol too has similar distribution across category. But if you look at volatile acidity, so for red wine, the less volatile acidity you have, the lower quality score you have. Whereas for a higher quality score in red wine section, the lower volatile acidity you have, the higher score you have, quality score you have. But in white wine, on the other hand, it performs similar. Like, but for both lower quality score and higher quality score, you do see a similar composition level of volatile acidity. And lastly, we have a embedded linear regression model, which gives us a predicted quality score. So on the user side, you could input. So these are all the variables that after we conduct our initial t-test that we deem as essential to predicting the quality score. So if you choose different level of input, it actually gives you the predicted value of the quality score. And you could also select different wines, so that will entail a different results as well. Yeah, so this is our shiny.
In our project, we did 2 parts of t-test in total. In the first part, we did a variable t-test on quality score. We conducted t-tests on each variable against the quality, regardless wine's category. The result shows that all the variables are significant to quality because all of them have p-value less than 0.05. In the second part, we did t-test against red and white wine. In this part, we did t-test to examine whether each variable is significant different between red and white wines. Because all of them have p-values are less than 0.05 and some variables even have p-values equals 0, which means they are decisively significant. So all the variables are significant to the quality